Okay, so what's the most important aspect of being of a job? Hazard and risk assessment for the safety of all involved. All right, number 2, training, a fit test, and a medical evaluation must be provided for employees utilizing which of these things? Each of these things, training, fit test, and medical evaluation, are required if I'm going to put people in a respirator. Nicely done. That's exactly right. Number 3, often found in older structures, lead and asbestos are hazardous and regulated materials. Is this true or false? And this is not meant to be a trick about whether they're new or old structures. Yes, commonly both these are found in older structures. Doesn't mean they can't be found, at least some of it, in newer structures. Question is, are they regulated and hazardous? This is absolutely true. Yep, they are regulated and hazardous. It's a big deal. Government puts people in jail for it. So, number 4, microbial growth is more likely to occur when relative humidity levels are which of these? What we're looking for in this one is going to be, so ASHRAE and CDC say that human beings are most comfortable typically about 35 to 50 or 30 to 55% relative humidity. If I'm up above that 60 or 66%, the higher the relative humidity, the more moisture in the air, the more chance it's going to move into materials through equilibrium. Down says, isn't the answer 66%? That's always going to be the highest number there. And since 66% is the threshold, starting a little bit high for my potentially some microbial growth. Number 5, anything higher than that would be taken. So I didn't put 66, I put 68 because it's more than 66. On the last one, my apologies, 67, 90, whatever. So great question. Thank you for that question. 66 kind of starting point. Anything above that just is where I can seconds on this one. Look at the clocks. We'll speed it up a little bit here. So about 5 more seconds. All right. If I'm cutting somebody off, I apologize. There we go. All right. If I'm working in potential contamination, see how we did on this one. The answer I'm looking for is going to be number 2, wear proper PPE. Now, if I don't want microbial growth, yes, I want to get my surfaces dry where it can't grow. But the question says if there's potential contamination. If there's potential contamination, I want to be very careful with air movers because that's just going to blow it around. So the best answer on this one is if there's microbial contamination or there's potential, it might be first I need to contain the area so I don't spread it out, and then PPE so I don't get it inside me. Any questions? I do the reviews. Well, sorry, number 6. On a project with mold growth or category 3, an assessment could be completed by who? The reviews are for me to kind of go through the information, make sure you got it, see if there's something I was going to talk about that I forgot to mention during the class part, and also for you to just kind of, cover it again. So it's also a time, any questions you have, this is, please ask me. If any of these kick a question somewhere, so. All right, see how we've done this one? Got a couple off, but. So category 3 mold, if I want to get an assessment done, that would be by an indoor environmental professional. Any of these other people might be able to do it, but that's the designation of someone who's qualified to do it, even with these other qualifications. And so a couple things on that, thank you. And they do the assessment, I do an evaluation. Alina mentioned I made a couple changes, and I realized that I have another PowerPoint that matches what you have, and a couple questions will be off a little bit, and I apologize for that. I thought I caught it and corrected it, so I will fix that. Thank you. And there might be a couple others as well. Secondary damage, number 7. Secondary damage is going to be, and I get a couple of answers on this all the time. So secondary damage is the damage that occurs if the water or humidity stays there over time and makes things worse. Swelling, growing, staining, all that kind of stuff. So number 3, initial damage, that right there is not it. That would be called primary damage. Damage that occurs prior to the water loss wouldn't be it. That's called pre-existing damage. And this one right here is the one that if people say that you're drying and something happens later on. The intent of number 2, where it says damage occurs after the drying portion of the job, is implying that you've actually dried the job correctly. So if I do the drying portion of the job, I didn't get everything and there's water, yes, secondary damage. If I get it all dry, there shouldn't be any more damage. So the best answer on this is secondary damage is the damage that occurs if the water or vapor stays in place for an extended period of time. If there's questions in this, let me know. Number 8, water that has a significant degree of contamination and could cause illness is which of these? On this, we're looking for the definition of category 2 is significant degree of contamination. Class 2, by definition, is a significant amount of water damage between 5 and 40. Category 2 is a significant degree of contamination. Number 9, when should carpet cushion always be disposed of? So if it's category 2 or 3 water, right? Category 2 or 3. So number 10, class of water describes what? I'm going to tell you about class of water. I'm referring to which of these? All right, we're looking for, this one's going to be come on there, computer, the potential rate of evaporation or evaporation load. A lot of times people pick number 3 because we've kind of quantified how many square feet are wet, but we're not quantifying how many gallons are in those materials. We don't know. We're just talking about the square footage of what's wet. I don't know how many gallons of water are in those materials. So what the best answer by definition on this is the rate of evaporation or the evaporation load is what the class is all about. Number 11, a drying chamber that has the greatest amount of moisture affecting porous materials over 40% of combined walls, floors, and ceiling materials is what class? So over 40% of my space is going to be a class 3 loss. If it's more than 40%, it's a class 3 loss. The most materials that's going to be wet in that one. Number 12, a drying chamber that has water bound in the materials. For example, hardwood or plaster, and has low potential evaporation, not because the water's not in there, just because it doesn't want to let it go, would be an example of what? Or what would that be defined as? So on this one, when it gets to bound water and there's no percentage, it's not going to be a 1, 2, or 3. It's going to be a class 4, no percentage, just the type of material that's wet, bound or trapped water. Number 13, which of the following would reduce microorganisms to a level considered safe by public health standards, the lowest amount of reduction, not the lowest reduction to, but the lowest amount of, is only reducing at the lowest amount of what others might do, if that makes sense. And yours might be worded slightly differently on that on your review. I'm not positive. Okay, so we're kind of all over the place on this one. The least amount is going to be, thank you, a sanitizer. Something sanitized is just, everything's not gone. It's just back to a normal condition. So I expect when I go to the restaurant, the table's going to be sanitary. I don't think it's going to be disinfected. I don't think it's going to be sterile. I think it's just going to be sanitary, where I can eat my meal on it and probably not catch anything. Okay, so number 14 says, and on each of these, if it has some sort of calculation, I'm going to show how it works on another screen. So I've got a crawl space that's 37. I accidentally closed it out. We'll just do this together. I have a crawl space that is 37 by 42, and the water is 1 foot 9 inches deep. And I'm looking for how many gallons of water, and the answer is 20,341 gallons. Sorry, I closed that automatically. Some of you, I guarantee, would have put number 2, 2719. Every class I get some people that select that. And so here's what's happening is, I just plug it in. 37, 42. The water is 1 foot 9 inches. 9 divided into 12 is 0.75. So 1 feet 9 inches is the same as 1.75 feet. I multiply those together and I get 2719. And I have people go, oh, hey, that's one of the options. We must be done. You're going to get that question wrong if it's an exam question, because it's not asking for how many cubic feet. You got to bring this down here and finish it 20,341. So make sure on the gallons of water that you don't solve for cubic feet, but you go all the way to the total number of gallons, or you're going to miss it. Number 15, once an area is identified with an infrared camera as suspect of being wet, we verify with what? What we're looking for in this one is going to be the infrared camera says, hey, that might be wet. I'm going to check it with a meter or a sensor. A thermal hygrometer just tells me temperature, relative humidity. That doesn't help me know if the materials are wet. That's just what's happening in the air. So this be a moisture meter or a moisture sensor. Number 16, psychrometric conditions have a direct effect on the rate at which moisture moves within and through materials. All right, what we're looking for on this one is going to be a resounding. This is absolutely true. So our psychrometric conditions are what's happening in the air. And the air is going to obviously make a big difference on how things dry. I'm going to go back to washing the car in January, washing it in August. It's going to dry faster in August off the driveway. Same thing with my materials. It's about the temperature in the materials, but the air has to support that process as well. So number 17, the amount of moisture in the air as a percentage of the maximum it can hold is known as, and that is relative humidity. Come on. There we go. Now, a lot of people on this one put dew point temperature because they see maximum. Yes, if I'm at the maximum, I'm at dew point temperature. If I'm at 100% relative humidity, I'm at dew point temperature. But the definition of relative humidity is how much moisture is in the air as a percentage of how much it can hold at that temperature. So this is the definition of relative humidity. 18 we just did, humidity ratio is the amount of water vapor in a sample of 1 pound of air, or 14 cubic feet-ish, roughly. Number 19, to promote effective drying, restorers need to control all of these things: temperature and humidity of the air, temperature of the surface, high vapor pressure, and well above dew point in my materials. Surface temperature, a surface with a temperature below dew point can result in condensation or dew, right? It's the point of dew. Number 21, providing dry airflow and increasing the temperature of wet materials, carpet, wood, into wall and ceiling cavities, under cabinets, assists for greater evaporation. If there's something you don't know, pretty much evaporation covers everything. So, number 22, if a drying chamber is 75 degrees and 40% relative humidity, what is the humidity ratio? What do I know? 75 degrees. Okay, that's right here. What do I know? 40% relative humidity. Okay, that's right here. So I know where I'm at. What does it want to know? 52 GPP. So I come over here and there's my GPP. I just plug in the two things I know and then go to what it's asking, and there it is. So if so it's 52 GPP is what it would be on that one. Number 23, when considering an open drying system. Okay, and so what it's saying is, if you're looking at an open drying system using the outdoor air, which of the following would be the best? Well, the best would be the highest temperature with the lower GPP. So on this one right here, I'm just going to bring up this other psychrometric chart and say that if I've got 4 different things on there, just plot each one and see what comes over here. And you want the lowest GPP with the warmest temperature. And so in this situation, 23, if I plot all these on the chart, I know that 40 degrees isn't very warm. I don't want that. It's 80% relative humidity. Definitely don't want that. 75, no, that's warm enough, but it's a high relative humidity. That's really warm, so the energy is good, but 45% at 90 degrees, a lot of water. If I plot this on the chart right here, that's going to give me the best of both worlds, the most energy, the lowest GPP. So that's what we're looking for in that one. 24, a room has 847 square feet of wet floor, 329 of wet walls and ceiling. How many air movers? 17 to 22. And the way we got there was simply going to my chart and saying, okay, 1 and 1 square feet of floor divided by both these numbers gives me 13 to 17. Square feet of walls and ceiling divided by both these numbers, 3 to 4. No insets or offsets, and I total those up. I'm moving fast. I think I might have mentioned I'll stick around if you need me to. And I'm planning on it. So, okay, number 25. Since desiccant dehumidifiers do not remove water vapor through condensation, they're not limited by temperature. I'm not trying to convert it. It's just grab it and spit it outside on each molecule. 26, in a class 3 loss measures 15 by 35, 9-foot ceiling. How many 100-pint dehumidifiers are needed? And that would be 2. Cubic feet, 15 by 35 by 9. My chart factor is going to be LGR class 3. That's 40. I divide that out. I need 118 pints removed. My dehumidifier does 100, and so that's 1.1 or 2. And if for some reason I don't have enough dehumidification, you can always put some plastic up if you can make your chamber smaller and do that with 1 dehumidifier. So there's a lot of ways you can adjust the equipment that's available for the job that you're trying to do. Number 27. 15,000 cubic foot drying chambers. I don't know calculations. It gives me the cubic feet. What's the initial recommended AHAM requirement or pints per day? Class 2 loss using LGR. That's 300 pints per day. And I know that because, again, I plug it in. Cubic footage is 15,000. LGR class 2 is 50. I divide by 50, 300 pints per day. It didn't ask about my rating or how many dehumidifiers. So I'm done right there with that question. Number 28. Warehouse 35 by 40 by 10, class 4 loss using a desiccant. How many CFM? Not how many dehumidifiers, how many CFM? The answer is 700. I'm going to go down to my desiccant part of the chart. Cubic footage is 14,000. 35 by 40 by 10 is 14,000. I multiply by 3 because that's my air changes per hour. So it's 14,000 cubic feet, but I'm actually processing 42,000 because I'm doing it 3 times. I divide that by 60 minutes in an hour, and that's 700 CFM. 700 cubic feet per minute times 60 minutes would be 42,000. You want to take it backwards. Number 29. A hardwood floor primarily absorbing moisture from the bottom and the sides, where the sides are higher than the center, is called cupping. That is called cupping. Number 30, I get to a water loss, has elevated humidity. If the outside conditions are warm and lower GPP, what could I do? Open the windows, open up that drying system, and allow some of that moisture to ventilate. If it's cold and outside, I might put an air mover for 4 or 5 minutes at the door, push it out, and then quickly close it to rebuild my energy in there. 31, what conditions would indicate the use of a closed drying system? If the GPP of the drying chamber is less than what's outside, close it off. I don't want that wetter air coming in to my space. That'd be a closed system. What happens when vapor pressure of wet materials is increased? Evaporation. If I warm them up, better evaporation, especially, well, in conjunction with the ambient air being drier and having lower vapor pressure. Less vapor, dehumidified, lower vapor pressure. Number 33, why should air movers not be installed when microbial growth or any other contaminant is either found or suspected? I don't smell it, I don't see it, but it's been wet for 2 weeks. I'm not going to put it in there because it will contaminate, could cross-contaminate other areas. The airflow is the perfect medium for getting that stuff to other areas. Number 34, to determine the amount of dehumidification necessary, what information do I need? So remember the 3 things I need, or my calculation for dehumidifiers on the chart is the cubic footage of my drying chamber, how much am I processing, how much am I drying, class of loss, potentially what's my evaporation load, how much moisture is coming in there, and what type of dehumidifier, because I need that in the class to find my factor. Number 35, what is the result when the air becomes warmer or there's an increase in temperature? Relative humidity decreases. Always the opposite. It's a teeter-totter. It's a seesaw. Temperature up, RH down. Temperature down, RH up. They're always the opposite. Number 36, why are desiccant dehumidifiers? Why are desiccant dehumidifiers often used in class 4 losses? They create the lowest vapor pressure of any type of dehumidifier. So they're great for class 4, bound water, trapped water, hard to get out. In a drying chamber that's 75 degrees and 65% relative humidity, okay, at what temperature could condensation form on materials? The answer is 62 degrees. So what it's saying is, if it's 75 degrees and 65%, when could I get condensation on materials? I could have worded this question said, if it's 75 degrees and 65% relative humidity, what is the dew point temperature? Because the dew point temperature is where condensation forms on materials. So if you see anything on any questions or in real life about condensation or about surface temperature, it is talking about the dew point temperature, because that's where the effect is. That's where it exhibits. Number 38. Which of the following is a vapor barrier or a vapor retarding material? And that would be a vinyl floor would be an example of that. It's designed so moisture can't go through it. That's good. But that also inhibits vapor from coming the other way. Number 39, why are LGRs or low-grain refrigerants generally more efficient than a conventional? Because they get a lower vapor pressure than a conventional. So drier air, better differential. Number 40, a material that is very weakened when wet, but if dried properly, retains its original strength, becomes actually more brittle, stronger, is gypsum wallboard, drywall, sheetrock, whatever you want to call it. Number 41. What is permeance? It's the indicator of the ability for vapor to move through a material. It's a rating of how vapor can move through a material. If it's non-permeable, then it's a vapor barrier. I can't dry through it. I've got to tear it out or dry another way from the other side. And number 42, if attempting to dry hard surface flooring such as tile and the subfloor, what do I need to do? Increase the heat or thermal energy. I've got to really increase that vapor pressure to figure out how to pull that moisture out.